maybe you are testing on the test set. This is a very common mistake.
Testing on data used for training,
and or even your test set is very unbalanced. So maybe you have only one class in your test set, and so.
Okay, what else?
Okay, maybe there is a bug on your code, but
that's
obvious.
Yeah, maybe I was saying that maybe your test set is not fully representative of the real world scenario.
Okay, and can I just say the obvious, the obvious thing, which is overfitting for some reasons, right?
Yeah, maybe your test set is very small. So when you go and use your model for in the real world, your model will perform badly instead, because he has never seen. So far he has just seen few examples. Oh yeah, that is more or less what Davide was saying.
Okay, so there are two different situations, right? So you have a measure of performance, and if this measure of performance is, what is the danger zone? Like, let's say that this measure of performance is a number between 0 and 1, where 0 is the minimum and 1 is the maximum. Where do you guys, you do machine learning every day. You've been doing machine learning every day for like the last 4 years. You know exactly, what triggers your attention, right? So in a classifier, what is the value that says, where you're saying, oh shit, there's something wrong, there's something going on here?
Either the measure of performance is, as you were saying, above 0.99, or is like 0.012.
Okay, so if it is too low or too high, you get an alert.
Yeah,
Would you agree that, Davide?
In general, it really depends on the size of your data set. For example, 99% for Tesla is not good, right? But if you have a data set of, 10,000 samples, yeah, there is something weird that you're doing.
Okay, so if it is smaller than 0.1 or 0.01, so this is alert.
Yeah, and also it depends on the number of different classes that you have.
Okay. But we all agree that very high and very, very low values are weird, okay?
Yeah, absolutely.
Okay, so if it is too high, we can overfit. There could be a problem with the training and testing of the model. So there are going to be a lot of different variants. So what we're going to do today is we're going to look at we're going to evaluate the performance of an object detector. This object detector was the one that we trained last week. And we'll see, we will draw some conclusions on how complex is the problem that we're trying to face. So I leave it now to Valerio, I guess, that will show some slides and we will take it from there. So if you share your screen.
Sure. Yes. Can you see my screen?
Yep, I'm gonna add it to the stream. Go ahead.
Okay. First of all, in order to evaluate performances, especially in a for a supervised learning task, we need ground truth. And by ground truth, I mean manually annotated data. For our specific case, that is object detection, let's suppose that we want to train a classifier that is trying to detect bolts. Well, this is how a ground truth appears. It's like a square around the target object. At a certain point, you train your model. And let's suppose that this blue square is what the model predicts for a ball. As you can see, there is some displacement with respect to the ground truth, but there is also some overlapping here. Basically, okay, yes. You can see this purple area. This is basically the intersection. And depending on how big is this area, we can say that this prediction is correct or not. There is a specific metric that we use in order to evaluate this overlapping area, and it's the intersection over union. Basically, this metric is computed like on the first number here is the overlapped area between the ground truth and the prediction. So this cyan area here, and you divide it by the union of the two areas. So as you can see here, this is the. Of course, if our prediction is exactly the same of the ground truth, you will get here 1. On the opposite, if there is no overlapping between the prediction and the ground truth, you will get 0. And then, of course, there are plenty of intermediate cases. So this is a key concept in order to then evaluate the performances of our object detector. First of all, the first metric that we can consider is the average precision. The average precision depends on 2 parameters. Here you can say this is the IOU, that is the intersection over union, and then the area. Let me explain them. Here, for example, intersection over union 0.5, 0.95 means that I do my predictions. I consider all possible values of intersection over union, starting from 0.5 up to 0.95. For each value of intersection over union, I compute the precision, and then I simply made the average.
Any question, Davide? Any questions?
Yeah, that area parameter, what is about?
I'm coming there. The area parameter is the second let's say input parameter of this average precision metric. And here you can have all the possible values for area can be all, medium, or small. And basically, if you have here all, it means that you are computing the precision on all possible objects that you have. Because in other cases, if you have, for example, here small, you are considering only small objects. And of course, small, medium, or all depends depends on the area of the object itself. So if, for example, let me come back here. For example, if the object to recognize is this ball, this is big enough, so it will be in the all category. Let's suppose that here we have a very little ball with a very small ear, then it will.
Okay, then this parameter is a little bit like cheating, because with this parameter you're able to discard all the objects that are small, and you can artificially bump your performance, right?
I would say it's not like cheating. Because if you consider all, you consider both big objects, small objects, and as you can imagine, detecting big objects is much easier than small ones. But instead, if you consider area equal to small, you are considering only small objects, and having here a high value of precision, it means that your detector is even able to detect very small objects. So that's a good model.
Okay, and what about these ranges of intersection over union? Why do we want to consider ranges of intersections over union?
Yeah, because depending on this threshold of intersection over union, you can consider a prediction as a true positive or a false positive.
Okay.
Of course, if you say my intersection over union is 0.9, you are saying that the ground truth and the prediction should be very, very close in order to consider the prediction as correct.
Okay.
And on the other side, if you put intersection over union 0.5 or even lower, even if lower values are not used, it's like you are relaxing some constraint and making the life for your model, let's say, easier.
Okay, and it makes sense because in some applications you don't need the perfect alignment, right?
Exactly.
You just need to get there somehow. You need to. So by playing with these two parameters, intersection over union ranges, or by giving the exact value of the intersection over union and the type of areas that you want to consider, you can really make this measure of performance very flexible and very adapted to the kind of problem that you want, to the kind of detection problem you want to solve. Is that correct?
Yeah. And I want to add another point. Of course, as you can see here, when you decrease the intersection over union, the precision will, of course, increase, and vice versa. So this intersection over union at the very end is something that depends on the specific use case, as you were saying, Luca. Because if you need very precise detection, then you have to cross-validate your model with a high value of intersection over union. Otherwise, you can relax this value and
that value. It's very similar to the threshold that you decide to put in a classification task, right? So if you want a high precision, you can increase the threshold. And
yeah, absolutely. This is one metric, and you can play, of course, with the intersection over union area. And the other metric that is typically used is the average recall. Again, here this average recall matrix has two input parameters that are exactly the same of the precision. And of course, there are intersection over union and the area. The meaning is exactly the same as before, and yeah, you can play with them according to your use case.
And what are the use cases where you would recommend to use average precision instead of average recall?
Well, if you let's suppose that there are. Okay, let's suppose that our system is a detector of people in a surveillance camera.
Yeah.
I would recommend to go for the recall, because if there is any bad guy, we don't want to miss him. We risk, of course, to trigger so many times whatever alarm is connected to the system. But yeah, at least if someone comes into my house, it's pretty sure that I will know it.
Yeah.
So in this specific case, I will go for the recall. While for the precision, I'm thinking about it. If you have suggestion.
Well, let's say that you want to alert. Let's say that there is a minor thing, a minor problem with I don't know. Yeah, there is a temperature of your house is going above a certain threshold, okay? And you need to alert the owner about overspending. So this is non-core, It's something that should be avoided. We shouldn't spend too much on heating, okay? But even if we do, even if this situation is not corrected, it's not the end of the world. There is no bomb exploding, right?
Yeah.
So in this case, it's not about the recall. It's about, the risk is disturbing the owner,
Yeah, absolutely.
the stakeholder or the owner. In this case, we don't want to disturb the owner, so we want very high precision. We want to, get the attention of people only when it's needed, or when there is something to correct, and we don't want to disturb these people when there is a false positive, right? And that's why we would use average precision instead of average recall. Make sense?
Yeah, absolutely.
So is it fair to say that in this case you want to be right? So when the action is expensive, use what? When the action is expensive, use precision, right?
Yeah, because otherwise we risk to spend money even if we don't need it. So maybe coming back to our original problem, that is detecting the marks on the on the newspaper pages.
And I put your screen in live again, Vale, so that we
No,
can.
but I don't have images
Okay,
for
so
them.
I'm going to illustrate that. No problem. Just talk to me, and I will do my best to illustrate this. Go ahead.
Yeah, let's suppose that we have our newspaper with our mark that we want to, on which we want to do object detection.
Yeah.
Well, I will go here for maximizing the recall, because in this way we are able to detect all possible marks, at least.
So what
And
you're saying is, even if I'm getting some false positives here and there, who cares, right? So this is a
yeah,
false positive, this is a false positive, but who cares, because it's not a big deal. I can always discard them
yeah,
manually.
you can build your app so that with just one click the user can
Yes.
delete them.
Would you agree with that, Davide?
Yeah, yeah, sure.
That is
Okay.
much easier than
Then creating a
go
new mark. Yeah,
and
yeah, yeah.
creating manually the highlights.
So what we want to communicate to our audience is that if the cost of the recommended action is high, this is high, this is low. So if we are high, we're gonna use recall. Sorry,
The
we're gonna use
numbers.
precision, right?
Yeah, yeah,
So
yeah,
this is precision, and this is recall, right?
yeah.
So this is very important. What else can we take into account to take this decision? Can we further restrict this rectangle or area, and maybe,
I mean, yeah, you should always also evaluate the cost of not taking that action. So, for
okay,
example, if you're analyzing medical images, you want to do a first filtering of the images. So you should maximize recall in that case, so that a medical professional can uh, view the images in a second moment.
so this is cost of inaction. Is that what you're saying?
Yeah,
Okay, so what we would do is, if it's here, low, high, we would end up in a situation where we have 4 different areas, right? Or not?
Um,
yeah,
I'm not sure. So can be the cost of action and inaction very high at the same time?
yeah. I mean, if they are balanced, you should maximize the F score, let's say, so the average of recall
Yeah, or
and
F1.
precision.
I agree
Yeah,
with that. So here there is F1.
yeah,
Here
but
you have,
see, it's hard for me to think about cost that a use case where costs of inaction and cost of action are both expensive.
no, but
There are,
let's say these are balanced, as David was saying. These are the 2 cases where it's balanced, and these are the cases where it is unbalanced, where there is precision and recall. Okay, I think it makes sense, but I think we could also review this graph. The important thing is that our audience understands there is a trade-off, and it depends what really matters to your application, and we can help you discover that. By the way, it's our job to take an application, take a problem, and determine whether or not you should optimize for precision or recall, and then what are the recommended thresholds to use in your classifier. Do we have another couple of minutes? Valerio, do you want to show the results of the classifier, and then add
well,
further comments?
okay, yes, basically the numbers that, let me share my
Yeah,
screen.
it's there.
Okay. Yeah, basically these were some numbers taken from the notebook of last week. Of course, we trained, let's say, offline for much more epochs. And yeah, we got these values here that are not so bad. For example, if you consider, in this specific case, an intersection over union 0.5, I think that is enough. We don't need a very a very precise location of the mark that we are.
Eh,
I mean,
More or less, I don't know, because then we have to guide the OCR. I mean, I think, okay, if these are the numbers, and unfortunately we have to wrap up today's live, but what I always do and what I always recommend to do in these cases is, okay, you look at the numbers, but the numbers don't give you the full story, right? So what you also have to do is to look at the qualitative results. So look at the output of your detector and see if these outputs make sense from a user perspective. So this is very important.
Yes,
Right?
absolutely yes. But I was thinking that even if my object detector is not very able to put the prediction exactly on the mark, again, here you can build a user interface where the user
Yeah,
can
okay,
just
yeah. I accept
can
that.
was drag and drop the
Yeah, the
detection.
rectangle. Yeah, I agree with that. Yeah, okay. Okay, listen, thank you very much, guys. So what did we learn today? We learned that that one, there is no silver bullet when it comes to understanding and qualifying the performance of a detector. There is this very interesting measure of performance, which is called IOU. Actually, it's a combination of IOU and average precision. We also learned that there are two parameters in this measure that are important for making your for adapting, sorry, this measure of performance for performance to your problem. And number three, we also understood that depending on the risk associated with the action that you would recommend at the end of the detection, you can use either precision or recall. Finally, last but not least, we also said that it's super important to always benchmark your application against qualitative results. So you have to see visually how this detector works so that you can really understand if your clients or users will be happy enough and will be able to take advantage and harvest value from that computer vision model. Do you have any further comments? Do you have any further observations to add, David and Valerio?
No, I'm fine.
What's the title of the next episode?
That's an excellent question. Let's have a look. I think it's how to easily deploy your computer vision model into production. And I think you're the expert,
Yeah.
and you're gonna entertain us with a lot of very interesting ideas. So thank you for watching. Please subscribe. That's very important to us. And if you want to, continue this conversation with us, just get in touch, and we will set up a meeting, and we will discuss your problem, finding the right measure of performance for your machine learning models. Thank you for watching. Bye bye.
Bye.
Bye
Bye
bye.
bye.